Morning, guys. We're going to look at local mins and local maxes. So first off, let's just do a little practice with domain and range. So if I look at the graph if I look at this graph here, okay, the domain is all possible x values. So I'm just going to build like an asymptote on each side of the graph to see how wide it is. And then I'm like, right here, the value is -3 and the value is +3. Both of these points at the end are included, so the domain would be from -3, +3 with brackets on the end, or in set notation, -3 is less than x, which is less than or equal to 3. The range is similar, but we are checking out the height. So we're going to do the lowest value to the highest value. Okay, the lowest value is 0 and the highest value is 4, and both those points are included. In set, that would be 0 is less than or equal to y, which is less than or equal to 4. All right, we're going to skip down to the local mins and local maxes because we should have already had the video for even and odd functions. So here we go. A local min is, so there can be lots of local minimums and lots of local maximums on a graph. So what you're going to do is if you see a point where the function changes from decreasing, so a decreasing branch pointing down, to increasing, you have a local minimum. If the graph goes from increasing to decreasing, you have a local maximum. Okay, so first off, let's just mark out which points are increasing and decreasing. So we're going to read from left to right. We're going to go, that part of the graph is rising in slope, so that's increasing. Then the next part here is decreasing. Then the next part till this point is going to increase, or from this point, and then this part here is decreasing, increasing, and then decreasing. Okay, so decreasing, decreasing, decreasing. So what are these points? Right here, 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 here. They're really neither increasing nor decreasing there. So these are what we call our local minimums and maximums. We just have to decide which one. So we're going to go back to the definitions. If we're changing from increasing to decreasing, then you have a local maximum. So this is a local max. This is a local max. And a local max. Okay. If you're changing from decreasing to increasing, you have a local min. I've also seen these called relative maxes and relative min. It's just like the maximum or minimum in a certain area. Okay. So we're going to list those points here. That's -1, 2, 3, 4, 5, 1. So local maxes, -5, 1. 0, 3, 1, 2, 3, 4, 4, 1. And then I have mins at 1, 2, 3, -3, -2, and 2, 0. The function, so now we're going to talk about pieces that are increasing, decreasing, or constant. So we write these as mini domains. I am always asking myself, if I think about the x as time, okay, then I want to, if I think about the x as time, I'm like, going to ask myself, what time is the function increasing? So if I look at this graph here, I'm increasing from, let's see, 6, from -6 to -5. So and we use open intervals, so from -6 to -5. So when x is -6 to -5. Where else? Okay, this part, from here to here. So -3 to 0. Or -3 to 0. And then one more section from 2 to 4. Or 2 to 4. All right, next we're going to do decreasing. So that would be from here to here. So this branch, okay? So that would be -5 to -3, or 0 to 2, or the last branch, which is from 1, 2, 3, 4 on to infinity. So +4 to infinity. I see I made a mistake. On the first increasing branch, which is this one right here, we don't actually start at -6. We start at -infinity all the way to -5. Okay, so in our calculator now, we're going to go ahead and look at local mins and local maxes. So I want you to graph the function here. Okay, we'll stop. Actually, we'll pause. Okay, so we graph the function in our calculator. You press y equals and then graph. The window should be -10 to 10 and -10 to 10. If it's not, you're going to press zoom 6 and it'll change it back to the standard window. Your graph should look something like this. So I'll go ahead and just sketch that in. So 2, 1, 2, 3, 4, 5, and 7. Okay, looks something like this. This is a very rough sketch. Kind of missed. There we go. Okay, so I can see that I have a local min somewhere down here and somewhere down here. And I have a local max at the top of the curve. Oops, sorry. I went back and I sketched in the function here. Okay. So now what I'm going to do is use the calculator to find the exact local min and the exact local max. I'm going to go ahead and just press trace right now and scroll over to where my local min, or I think my local min is. But notice that the cursor jumps around, so I can't put in like an exact value. So this is an approximation. To get the exact value, you press second trace, okay, second trace, and then we're going to scroll down to minimum. Now you have to repeat this process for every local min and local max. So since I have 2 local mins and 1 local max, I'm going to have to do this process 3 times. So first it says left bound, and so I'm going to choose a point that's left of my local min, and I'm going to try and get the value of this first one on the left. So that my cursor is left of the local min. I press enter, and then I go to the right of the local min, and then it says guess at the bottom. So I press enter one more time, and it tells me my local min. The exact value is -0.822 rounded, comma, -9.774. Okay. Go ahead and write that on your graph, and we're going to do this again. So we're going to go for this top maximum. So we press second trace. Oops, second trace. And we're going to go to number 4 for maximum. So This time we're going to get closer to our maximum. So left of the maximum, right of the maximum, on the maximum as best as you can. So then I'm going to write this on my paper. 2.917, comma, 8.017 rounded. And our last one. So this last minimum, we'll do that process again. Second calc, minimum. Okay. Then we're going to go to the left of the minimum. Then we're going to go right of the minimum, get close to it, and enter one more time. And we see the minimum is 6.154, comma, 6.155, comma, negative 4.102. And we're going to stop there and then look at absolute mins and absolute maxes in the next video.